Okay, now coming to what I was discussing earlier, inheritance. So inheritance is a very important concept. The philosophy behind inheritance is code reusability. Okay. So what I write in one class, I should be able to reuse it in another class. I should not invent a new class, having more or less similar features as the old one. So this is one feature which is extensively utilized in C++ or in any other object-oriented programming language. So there are different types of inheritances. So if you look at this diagram here, there is a single inheritance. It means one subclass can inherit only from one base. Okay, this is what we saw in our earlier example. So there was a base class and we were inheriting from the that base class into a subclass. This is single inheritance. Okay. Then inheritance levels can be further extended. That is B deriving from A and C deriving from B. And this can just go on like that, like another D deriving from C. This is called as multi-level inheritance. Okay. And there is just multiple inheritance. This is to be understood correctly. There is a difference between multi-level and multiple. Okay. Multiple means there will be more than one base class from which you can derive into a subclass. This case we have not seen so far. Okay, so we shall see how we can inherit from more than one base class into a subclass. Of course, there are certain issues which you need to address. Suppose there is a method M1 here and same method M1 is here. So then what happens? Okay, so there will be a conflict and we need to resolve that. Okay, and then there is a hierarchical inheritance, which is a combination of uh, multi-level and also multiple inheritance. As you can see here, uh, B is inheriting from A and C is also from A only, but D is inheriting from both B and C. As you can see, there is a cycle here. So here also you will have a lot of problems when you have hierarchical inheritance. All right. So
This is diamond, right?
yeah,
Diamond in.
yeah, diamond. So because of the shape of the cycle that is formed, it's also called as, it leads to what is called a diamond problem. Okay, so we shall see what is that problem and how we can address that. Okay, now when you have multi-level inheritance or even single inheritance, we need to understand what is the order of invocation of constructors. We know that there is constructor in base class and also in all the subclasses. So in what order the constructors are called? Even in multiple inheritance, there is a constructor in A and also in B. So in what sequence the constructors will be called? So there is a simple order to be followed. The order of invocation of constructor is from base class to subclasses. That is, when you create an object of class B, the constructor of A is called first. Okay. In the multi-level, when you create an object of C, the constructor of A is called, then B is called, then C is called. So this is the
So
order of,
here, sir, sorry to interrupt.
yeah,
So here, B class B is the base and class A is the subclass or parent class.
yeah. Class A is a parent class for B,
B.
and B is a parent class for C.
Then what is this you have written like subclasses, base to subclasses?
That's what from when I say base means anything above certain class is base class. No. For example, class C is the child class or the grandchild of A. So parent of C is B and parent of B is A. So when you create an object of class C, the constructor of A is called first and then constructor of B and then constructor of C. In that order, the constructors will be invoked automatically, even though you are creating object of class C. Whereas in multiple, again, it is from base to subclass, but since there are two base classes, first the constructor of A is called, then constructor of B is called, then constructor of C is called. Do you see
Mm-hmm.
the sequence? And in
Mm-hmm.
hierarchical, when you create an object of D, constructor of A is called, then B is called, then C is called, then D is called. If there are two clauses in the same line, it is from left to right. And if there are no clauses in the same line, it is vertical. Okay, so that sequence you have to remember. We'll see the demonstration of that if you have still some doubts. Now, there was one more question from your side that what happens if I inherit a class publicly or protected way or in private way? This question you had asked me earlier. Let us say we have a class A and class B. And in class A, there are three members. One is private, that is X is private, Y is protected, and Z is private. Okay? Is it private or? Oh, I'm sorry. This should have been public here. 1 minute. First one should be public. So let us say there are all three kinds of hmm, access specifiers: public, protected, and private. Now, what happens to these three variables when I inherit this class into B? Okay, using public keyword after the colon, or protected keyword after the colon, or private after the colon. Now, if I use public, whatever is public will become public here, and whatever is protected will remain protected, but whatever is private is inaccessible. So in the first case, that is case 1, here in class B, this will remain public, this will be protected, okay, and this is inaccessible. You cannot access Z because it is private, even though you are publicly deriving class B from A. Is that point clear? Okay. Now let's see what happens when I derive it with a protected keyword. What is public will become protected here. What is protected will remain protected, and what is private will not be accessible again. Do you see the change now? Okay. Now, if I derive using private keyword, then what will happen? This public will become private here, and protected will also become private, and private here will again remain inaccessible, right? So there is a implication of using public, protected, and private keywords after the colon. So if you want to retain the access specifiers as they are in the base class, it's better always use public. And that is what we have been doing. We are always saying colon public. Okay. But in certain other situations, we want them to be protected. So you can use protected. So that every member of base class become protected in the subclass. And anything private will remain private. So that is going to protect the encapsulation principle of OOPS. All right. So these were some of the finer details which we missed out last time, and I've covered it here. Okay. Now let's go with the demonstration of the different type of inheritances. Now let us see single inheritance we have seen. We'll see multi-level inheritance first. So assume that we have class A, and within this we have an integer x, and we have a constructor which will accept some value A, and it is used to initialize value x using the parameter A here. So this is how I would initialize the member variables. And if you want, you can have a display function here just to display what is the member variable in that class. So you can say I am, or x is equal to just this x. And if you want to indicate that you are calling the constructor, I am constructor of class A, right? Yeah. So same thing I will do it for class B, of course with different member variables. I'll just copy paste so that I can save time. Class B here, and here I will have member variable as y, and this as B. This is constructor of B. Then I'm going to initialize that with value B here, and here constructor of B, and display, I'm going to display Y. All right. So similarly, this I'm going to derive from A using public, because this is single inheritance. All of you agree? Okay, so let's see in single inheritance what happens. Suppose if I create an object of B, I have to pass some value, let us say 5. Okay, okay. So when you call this, you must call the constructor of A before you call the constructor. I have to send two values here, A comma B. One should go to A, another should be used with this. And here I should be passing two values. It should be int B here. I'm calling constructor of A and then initializing the member variable. Okay, now I forgot to include public keyword here, so that is why it is not allowing to access the constructor. Similarly here, constructor B should also be in the public section. So just see how quickly we can go wrong at many places. So we have to be very, very careful when you create the classes using inheritance. Now everything is fine. Now what do you expect when I create an object of class B? Do we get which statement will be displayed? I am constructor of B first or I am constructor of A first?
A first.
A first, because that is how the hierarchy is maintained. So let's see whether that is happening. I am constructor of A and constructor of B, right? So from parent to child. If you had one more, then that same sequence will be followed, because this is multi-level inheritance. So let us say I have class C here. Tell me if I go wrong somewhere, which is inheriting from B, and it has a member variable Z, and its constructor is C here. Now it should accept three values, and it should pass one to constructor of A, constructor of B. Oh, I cannot call constructor of A here. I just have to pass A comma B here. Yeah. I can only access the constructor of its parent class, where I will pass A and B. Constructor of B is taking two arguments, right? So I'm passing A and B. Still it is that error was just showing just like that. Yeah. Now if you see the sequence, I am constructor of A, constructor of B, and constructor of C. All right. So B being base class of C, only the constructor of B can be called. I cannot call constructor of A, which is the grandparent of C. Okay, so I had to go through B only. So that was a mistake which I have corrected it here. So you see the sequence of invocations from uh, grandparent to child to grandchild. Okay, so that is the order that is followed for the constructors. Okay, so let's see what do we mean by multi. This is multi-level inheritance. Okay, then we need to look at multiple inheritance, right? So in that case, can you tell me what all changes I should be making here? Assume that B is not inheriting from A. So I'll remove this. So B is just a class and it's going to take only one argument B here. I'm going to initialize this. I've removed inheritance from A. B is a independent class and we have everything else as it is. Now class C, if it wants to inherit from both A and B,
Comma. A comma B.
Yeah, so you got it right. So then what should happen to the constructor here? Here constructor of B can be as it is, then constructor of A should come and Z as it is. So this is multi
Multiple.
multiple inheritance. Okay. Now what will happen to the display function? So should it be virtual? So if you make it virtual, then there is no problem, because it will look at the first virtual in class A, and you are overriding that here in class C. You can mention that you are overriding.
Just over it.
Yeah. Okay. Now this is same way, and if I say C dot display, it should call the overridden method here. Okay. You can say I am C class method. Hope everything else goes through correctly. Yeah, and C class method Z is 7, right? And as you can see, the order of invocation again is maintained, and it is from left to right, A to B, and then to C, even though it is multiple
So
inheritance. Yeah.
if we don't give a virtual and override, which display it will call?
That is the problem, because there will be two
What error it gives, like
yeah,
on
we
this?
will check that. In fact, it should give error, because yeah, it gave already. Yeah, display override is not allowed, because base classes are concrete. Okay, so they have to be virtual for the code to work correctly. When you have two versions of the same method, uh,
No, so somewhere override it is
Sir,
like
yeah, 30th line, you have a override
okay,
given next to
yeah,
that
let,
method.
let me check. If I remove that, what will happen?
uh, yes.
But it's not mandated to give override, right,
Yeah,
sir?
yeah,
If you just make it virtual and leave the last child
yeah.
class, it should take that.
Now it's not overriding. It is just implemented here, so it will use its own method. But suppose if I remove this and then try to call one of the base class methods, which method does it use? So that conflict will come. No, now it will say something is wrong, is ambiguous, as you can see. Okay, if you define it in C, it works fine. But if you are not defined display in C, there are two versions of display. Okay, in A and B, so it doesn't know which one to use. That confusion compiler cannot resolve. So best thing is to say virtual and override it here. Now also if it is virtual in both things, again you have a confusion. So when it is virtual, you have the freedom to override it. So you are overriding it like this. Okay. So you need to override the method and use it, and making the base class method virtual. That is how it should work. All right. Now moving on, we need to look at what are pure virtual functions and what are abstract classes. Okay. So I told you virtual functions are functions within the base class which can be overridden by the subclass. Now overriding the virtual function in subclass is not mandatory. We have seen this. Suppose if you want to force the subclass to override the virtual function, then you have to make it pure virtual function. The way to make pure virtual function is simply equate that function to 0. This is not any mathematical equation here, but that is a notation to indicate that this is the pure virtual function which has no implementation in the base class, but the subclass has to override this compulsorily. Okay, so class A has a member variable x. It is initialized here, and there is one virtual function which is equated to 0. It is pure virtual function. The moment make one of the method as virtual, there is one more virtual method which is defined here. This is not pure virtual function. This is the regular virtual function which can be overridden by the subclass. So the subclass has a choice to either override this or leave it. But when you make it pure virtual, the subclass has to implement it, has to override this. Okay, so that's the compulsion that comes through. And any class which has at least one pure virtual function is called as abstract class. Okay, so here class A is abstract. And any class which is abstract, you cannot create objects of this class. You cannot say A, comma A file like this. Creating object of this class is not allowed. That is because you don't have definition of one of the methods here.
But we can inherit.
Yeah, you can inherit. Okay.
So
So
how is it is different from that virtual we are creating, like right? Previously you have shown, no?
yeah,
Override.
the override is fine. Overriding regular virtual function is allowed, but that is not mandatory for the subclass to do it. Okay. Whereas this virtual function, which is equated to 0, which is pure virtual function, has to be overridden by the subclass. Otherwise, you know what happens? The subclass will also become abstract class. Subclass cannot be instantiated. You cannot create objects of the subclass also if this is not overridden. Okay. So if the subclass has to have its own objects, then it has to compulsorily override this. Now, why it is done like this, we shall see through an example. Okay. So for now, you understand that pure virtual functions will not have any definitions. They are equated to 0. And the subclasses have to compulsorily implement the pure virtual functions for those classes to be able to create their objects. For instance, here, class B is inherited from class A, and within the body of this, it has to override the show method. Okay, so the pure virtual function is implemented by the subclass. Now B is capable of creating its objects. Okay, now if you look at this simplistic example, it doesn't make sense. I mean, you are wondering why you want to make something as pure virtual and override it here. All right, we shall see a more concrete example to illustrate the use of abstract classes. Okay, yeah. So shall we see a demonstration of this? Or you have
Yes,
some
sir.
doubts?
The doubt is again why this virtual, pure virtual is needed. What is the
Yeah, yeah.
real use case of
Okay.
that? But maybe demonstration would give that
Okay.
answer.
See, I'll give one very simplistic example. Let us say there is a class called as shape. Okay. You have geometric shapes, no? Circle, triangle, like that.
Hmm.
But I create one class called as shape. For shape, if I say compute area, can you compute area of a shape? Unless you know what shape it is, you don't know how to
Hmm.
calculate that area, isn't it? So in that
Hmm.
case, shape is an abstract class. And in that, the virtual function compute area should be pure virtual. And subclasses like circle can inherit from shape to
Hmm.
implement that compute area, because when you go to circle, you know there is a radius, you know how to calculate area. Similarly, if you go to triangle, you know how to calculate the area, base and height. So the concrete classes which derive from abstract class know exactly how to carry out that particular pure virtual function. Now the advantage is you are forcing the subclass to implement it, and if whenever you use the base class pointer, see, class A is abstract. It doesn't mean you cannot create a reference variable of A. Only thing is you cannot create object of A. However, you can create a reference variable of A. For example, I can say A star, okay, PTR. This I can do. This is a reference variable of class A, right? And I can assign it to object of class B. assuming that B is a subclass of A. This is possible. The reason why it is done is that now I can use the pointer notation, that is ptr arrow, and call show method here. Okay. So the purpose of abstract classes will become very clear when I take more concrete example. I gave you example of a shape. Now another example would be, let us say there is a engine class, right? You have a car and within that there is an engine. Now the kind of engine that I fix, that may be from Toyota or maybe from Hyundai or from the Maruti. Depending on which engine I fit, it should still function. In that case, the engine class has to be abstract, and how the engine should function is implemented by the subclasses, namely the Hyundai engine or Toyota engine or Maruti engine. So we shall see a concrete example to make you understand why there is a need for abstract class and why there is uh, a pure virtual function within abstract classes. All right. Okay. So let's see the example in action. We'll take one more file here, abstract.cpp. Now let me take the example which I was telling you. Let us say there is a class shape here. In this shape, the shape can be positioned anywhere. Let's say it has a coordinates int x comma y. Right? These are the two member variables. Here I can have a constructor in the public section shape, and I'll pass int a comma int b to initialize these two values, xa comma yb, and then end it with flower bracket. So my constructor is ready. Here I will have a let us say you want to return the area, compute area. There's a method. Now this compute area, if you try to implement, I don't know how to implement because shape only is not known, right? Obviously this is a virtual function and pure virtual function, because I cannot define it in the base class. I'll make it pure virtual, but I must use the keyword virtual here. Okay. So now this becomes pure virtual. The subclass has to implement this. Along with this, you might have just a concrete method also. In abstract class, you can have concrete method also. For example, void show. I can just print cout x and y coordinate of shape is just x, and then in between there is a space, and then there is this y, and then there is handle. So abstract class doesn't mean you cannot have uh, concrete methods. You can have concrete methods along with virtual function and pure virtual function. It can have virtual function also, normal virtual function, right? But moment you have at least one virtual function, this shape becomes now abstract class. So this is a abstract class. So I told you that object-oriented programming has four pillars. One of the important pillar of OOPS is abstraction. That is, you expose only the essentials and hide the details. So here I'm exposing only the XY coordinates of the shape, but I'm not telling you how I'm going to implement compute area. So that will be done by the subclasses. So class circle, it is going to inherit publicly from shape. And here you might have one data member rad, and in the public section we'll have the constructor circle with three arguments, int x comma int y comma radius, and within the body of this we can pass xy to the base class comma initialize rad with r. So this is the constructor of, it should be int r here. right? Now here I have to implement compute area, that is float compute area. I know how to do this, right? I just say return pi star rad star rad. Just that I have to define this final float pi equal to 3.142 f, some constant, the pi value. What happened? Oh, I'm using Java syntax here, sorry. It should be const, correct? Yeah. Now you see your class is ready with a concrete implementation of compute area. Now I create a shape reference variable, rs. Now this can point to the circle object because for circle, shape is the base class. As I told you, base class reference variable can point to a subclass object. Exactly, I'm doing this here. So let us say it is at coordinate position 30 by 40 and the radius is, let us say, 5 is a float value. Now if I say S arrow, you will see compute area will come. Now compute area being pure virtual function in shape class, it will go to the subclass for its implementation, and now you will see the area of circle getting displayed. Since it is returning the value, I should display it here with the cout area of circle equal to, yeah, should work fine. All right. Now you might wonder what did I achieve using abstract class. Is again polymorphism is achieved. Okay, because now the same shape pointer can point to a circle object, right? S equal to new, sorry, triangle object. If I have a triangle class with some xy values and let us say base and height are 4 and 3 and 4. So I need to create a class triangle here which will inherit from shape, and it will have two data members int a comma base comma height, and in the public section you will have a constructor with int x comma int y, and here int c comma int d. Just to avoid conflict with b and all, I'm using different notation here. So what should happen? I should pass x and y to shape and use b to c value to initialize b and d value to initialize h. Now suppose if I don't implement compute area, which is pure virtual function here, what do you think what will happen? Okay, what it is saying, object of abstract class type triangle is not allowed. Triangle is not abstract class, right? Because it doesn't have any pure virtual function. Since it is not implementing the compute area, it will also become abstract class. If you
So
can see.
31 line is the shape.
Pardon?
That should be shape. 31 line.
Yeah. Okay. Yeah. Okay. So we are not able to create object of triangle here because it is mandatory for the subclass to implement the pure virtual function of the base class. Unless it does, you cannot create object of triangle. Are you getting this point?
Yes.
Yes, sir.
Okay. So this is how the mechanism is built into C++, where the subclass has to mandatorily implement. So here, if I now say float compute area, here I know how to compute the area 0.5. Now things are okay. That error is gone. Now you will get the object created of triangle. Now if I do the same thing what I've done here, that is if I see out the compute area, you will see now area of triangle is found. Now this concept of abstraction, we need to take more concrete example to illustrate what is happening here. I'll give one practical example. Let us say you have a car and there are the four wheels are there. If whenever your tire is worn out or something is damaged, you want to replace that car with a new one, right? Originally, all of them are, let's say, Wheatstone Bridge or some company, Apollo or something. Now, when you go to the market and try to buy Apollo, if it is not available, then what will you do? You look for alternatives, right? MRF you buy and try to fit there. Okay, so it should perfectly fit there. So the wheel drum is designed such a way that, or the tire which, I mean, the drum which holds the tire is designed such a way that it can accept tire of any company. That is the abstraction. Okay, so that is the same logic that is applied here. Irrespective of which object you are creating, if this shape is executing compute area, irrespective of what object it is pointing to, it is using the same method compute area to get the result. Okay, so code replacement will be very easy. Today, let us say in a software you are using a circle object to carry out some task. Tomorrow the need arises that it should be done by a triangle. Then what will you do? Are you going to rewrite the whole code? Definitely not. You just want one line change. Okay, just replace this circle by triangle. If I do it right here, I am not changing anything anywhere. Just that this object also takes one extra value here. You have to pass appropriate number of value. That is the only thing. Let us say something like this. Just see, I've just made one change, and instead of triangle now circle, it will find area of a triangle, maybe a different triangle, isn't it? So replacing one object by another is so very easy if you have concept of abstraction. So as you can see, both are triangles now, finding the areas in a with a different values. All right. So the code replacement becomes very easy when you have a concept of abstraction. All right. So would you like to try this out?
Yes, sir.
Yeah, just give a try because this concept itself is very difficult to understand unless you get a big picture in what scenario abstraction is used. So I have to take more examples on this. We'll do that subsequently, but a simplistic example like shape and circle triangle should illustrate the use of pure virtual function in the base class and overriding that pure virtual function in the subclasses. Yeah. So do not worry if you have not followed anything very clearly. We shall see more examples of these kinds in our next session. Okay. So to summarize what we have discussed today, we considered the example of lambda functions for a more serious applications like credit card validation, that is using a lambda function injection into a method. And we looked at different types of inheritance: single inheritance, multi-level inheritance, multiple inheritance. And also we looked at hierarchical inheritance. And through a code demonstration, we saw what is the order of invocation of the constructors when there is an inheritance. We also saw the effect of using public inheritance, private inheritance, and protected inheritance. So what happens to the member variables when they are inherited publicly, privately, or in a protected way? And we started off with abstract classes. Any class which has at least one pure virtual function, such a class is called as abstract class, and you cannot create objects of that class. However, you can create pointers of that class and make it to point to a subclass object which implements the pure virtual function. So we saw the demonstration of a shape abstract class which is implemented by the circle class and triangle class, and the demonstration showed how we can replace the object pointed to by S either by a circle or a triangle, and get the results as required. Okay, so we shall see more on these things in our next session. All right. Hello everyone. Hello, good evening everyone. Welcome to my channel. Watch my video on Oops with C++ till the end. If you like my video, click on the like button and subscribe to my channel. Thank you so much. Everyone, good afternoon. Last class we discussed about lambda functions and how to put lambda functions inside the class and again inside a method. And also we saw how we can inject a lambda function into a method. Last time I mentioned to you that we need to look at another example where we can either inject a lambda function to carry out certain important task, or we can use it within the class. So here I have taken an example of a credit card. So you all know that before any payment is made, you need to verify whether the credit card number, expiry date, CVV and customer name are all correct. Okay, so in this class, credit class, I am going to model that. So I have captured the card number, expiry date, the CVV, customer name, and I have added one extra field, which is balance. Now within the constructor here, I initialize the data members. Only thing is balance I'm initializing by default. All others are initialized through a parameterized constructor. Then I am going to add a method verify card, and within this verify card the first argument is a lambda function which returns a string indicating whether the card is valid or not, and it accepts a couple of arguments here. The first one being the card number, which is a 16-digit number which I have modeled as a string. Then we have the expiry date. Then CVV I have modeled it as a short int, and the name of the customer is string again. And this lambda function is named as card vendor, because each card vendor, maybe Visa card or MasterCard, they may have their own card series and maybe a specific CVV number series according to which the validation has to be done. And within this, I am going to call the lambda function card vendor. Similarly, in make payment, I have in method lambda function where I am going to make payment through a gateway like PhonePe. And here again, I am going to check whether the amount that the customer wants to transact is within limits or not. So this could have also been done from outside the class, but just for an example, I'm doing it here. And in the main, what I do is I create an object of credit card. So I'm creating two objects. One is Visa card, second one is MasterCard. So Visa card, let us say they start their card series with the first number as 6. Rest all is some combination of numbers, and the expiry date depends on when the card was issued. And we have a CVV. Again, the series depends on the card vendor. It could start from 100, 101 like that, or start from 200. It is just 3-digit number. And then the name of the customer. In the MasterCard, the card starts with a series 9 here. Possibly you can change the CVV to 103, and the name of the customer could be something different. Let us say some Ajay, some surname. Now just observe here that I have a lambda function here which takes these 4 arguments as inputs, that is card number, expiry date, CVV and the customer name. So I'm not going to check the customer name here. I'm only going to check whether the CVV number is correct and the card has a starting digit as 6. That is why we know that this is a string, and string individual characters can be accessed through the index. As you know, string is a array of characters, so that is why I'm using cnum in square bracket 0 equal to single quote 6. It means I'm extracting one character from here and just comparing whether it is equal to 6. It means I conclude that it is a Visa card. If it is 7 or something, it will not match and it will give card invalid statement. Okay. And the expiry date,
Sir, why it is, sir, why it is used array of characters? Can you just explain, sir?
yeah, see, this is a string, no? This is a
Correct.
string. String is what? Array of characters or
Huh?
array of numbers. So this because I want to extract only the
Oh,
first
only the
character.
first value. Got
Yeah.
it.
In fact, there are methods to extract the first character. Probably there is a method on string called char at. So if you use that also, you can extract the first character or any character at any particular location, right?
Okay.
Yeah. So if you want to test all the first four digits, then you have to say char of 0 equal to 6, char of 1 equal to 2, and like that. So more elaborate checking can be done. I'm just for demonstration purpose checking only the first digit. Okay. So if the card that is passed is having all the data correct, then it will return your card is valid. Otherwise, it is invalid. For MasterCard, I am going to check whether the series starts with 9 and CVV is 103. I think so I have given 103. Yeah. So if I give wrong CVV, you will see that the second transaction will fail. If I use MasterCard, it will fail because your card is invalid. Here I am checking in the MasterCard whether the CVV, okay, is 105 or not. But what I am passing here is 103. Obviously, this will not match. So it should give me a message saying that card invalid when I to try to do some transaction with MasterCard. So let's verify that using Visa card. I say verify card and I send the Lambda function with the data which I've captured there. Same data what I've typed here when I'm creating the object, exactly the same data I'm passing in the verify card. Okay. So this will go through. The second one, MasterCard verify, where card series is correct. Okay, expiry date is also correct, but the CVV is wrong and also the name is also wrong. I've just put some other name here. So two conditions are failing and this MasterCard payment will not go through. Okay. And if you want to, after the card is verified, if I want to make payment, I'll call make payment and pass 4,500. Okay, so here I'm sending 4,500. If I want a transaction to be successful, because the balance is 5,000, you should send something less than, uh, let us say 4,000, so that transaction goes through. So now if I run the program, you will see Vijay Sarnobat, your card is valid. So Visa card is valid. The second one, Shreyas Tonpi, your card is invalid because his name is not matching nor the CVV is matching. And this transaction is successful. All right. So we can implement Lambda functions for a more complex applications like this. Right. Any doubt here?
Sir, name are we matching? Uh,
Uh,
can you
na-
just pull it up?
name I have not considered. Okay. So you could do that also.
Yeah,
Yeah.
but the transaction failure is only because
Yeah, only because of the
the
card number is not matching.
it's not matching, correct?
Yeah, if I
Okay.
make the card number match, no,
Hmm.
possibly the second one will also go through. Let us see. Card
Okay.
is valid. Okay.
Okay.
So I'm not checking the name. So if you check the name also, this time it should fail. So are you now comfortable with Lambda functions or you still
Yeah,
have
yes,
some
sir.
doubts?
So can you once explain this code because I joined late?
Oh my God. Okay. Uh,
Yes.
Others also I can explain, but one small
Mm-hmm.
uh, explanation I wanted to do. Last time I told you that if you want to reference any member variable with reference, it should be ampersand, right?
Mm-hmm. Right.
Only then the change will happen. Now, and I told you that if I put equal to it is called by value.
Correct.
Now I verified with online GDP that for version C++ 17, it
Mm-hmm.
will treat both ampersand and equal to in the same way.
Okay.
Uh,
Oh.
it will allow you to modify within the body of this. Okay, it is called by reference only. But if you go with C++ version 17 above, that is version 2023, it doesn't allow you to change this. So it is version dependent. I think so. In your case, it was working because you are using some older version of C++. I guess Arpita, you are using online GDB.
Yes, sir.
So there, the version that you might have chosen is just C++, which is some old version. There, if you make a choice of C++ 20, it will give. Yeah, maybe that is some additional feature that might have been included. But I verified with the documentation. That is how it was mentioned.
Okay.
So
But I
that's
was
just,
using that C++ 23 only, sir.
yeah. Then probably the documentation given by ChatGPT may be wrong.
Yeah.
Yeah.
Yeah. Yeah.
So if
Okay.
at all if it is not working the way you are expecting, probably that is the reason. It is
Okay.
some version dependent. So Faisal, what I was explaining here is a new
Mm-hmm.
example where credit card validation has to be done. You know
Okay.
that credit card can be supplied by many vendors. It could be
Right.
MasterCard or Visa card or any other. So each one will have their own way of validating the card, right? So I'll show
Mm-hmm.
you the main function. Possibly you'll pick up fast. So in the main,
Mm-hmm.
what I'm doing is I am creating a Visa card.
Mm-hmm.
Okay, Visa card will start with the series number, let us say 6, right?
Uh-huh.
And their CVV will start with the series 200, 201, like that.
Mm-hmm.
Other things we don't have much control, like the expiry date and name depends on the customer when he has taken that card and all. We need to
Mm-hmm.
check whether this card is valid or not based on the first character of the card number and
Mm-hmm.
also what is the series number. Here I am checking whether CVV is equal to 203 and first character is 6. Yeah. I have created two lambda function, one for Visa card and another for MasterCard. In MasterCard, I'm checking the series starting from 9 and CVV is 103. And just for illustrative purpose, I'm checking whether the expiry date is matching what the customer has sent.
Mm-hmm.
We could include the customer name also. So these are the two lambda functions in main, and
Okay.
the Visa card object has a method called verify card,
Right.
where I pass the lambda function as the first argument and pass the exact card number.
Mm-hmm.
So here this card is starting with the series 6, so that matches, and the card CVV is 203. Only these two are checked, right? So even if
Okay.
I make a change in other digits, it will take it as a Visa card only. So now if I run the program, the Visa card will go through.
Mm-hmm.
That the first customer, Vijay, whatever name, is valid. Okay. Whereas
Mm-hmm.
MasterCard, what I've done is I have deliberately introduced some mistake here that CVV, though it is 103, I'll make it 203. So it doesn't match, and you will see second card will not go.
Mm-hmm.
Your card is invalid. Okay, only when you
Right.
supply the correct series number, it should work. So if the CVV is right and if you are passing a Visa card here with digit 6 here, it should again pass. So the reason why I took this example is in a more complex case like this, how lambda functions are
Mm-hmm.
useful, right? So you can inject the lambda functions within the methods of a class and do the validation,
Mm-hmm.
right? Just as the way we
Yes.
did with the gateways, right? You can
Mm-hmm.
verify the card while making transaction using a card at an ATM.
So, sir, this lambda function, can we give default parameters and value in lambda?
Where?
Where in the lambda function where you have,
Okay.
uh,
Here.
if I want to set some default, right?
Yeah.
Maybe string.
So that should be possible, I guess. 103 like that. And
Mm-hmm.
if I don't pass, will it work or not? That is what we have to see. That is MasterCard, right? So if I don't pass,
Maybe that default has to go in the last, right to left.
oh yeah, that condition has to be applied. It should start with the last one, right? CVB has to be at the last. So those variations we can check. Should work because lambda function is nothing but a function only.
I will try, sir.
Yeah, you just give a try. All right. So shall we move on from here?